Okay, look. So, we're going to talk about the water cycle.
Water cycle.
So, water cycle, also known as the hydraulic cycle, is the journey water takes as it circulates from land to the sky and back again.
Did you look at my tag to see is there to stop?
So, the water cycle goes from what to what and back again?
From land to sky and then back again.
Yes. So, it kind of goes
In a circle.
from land to sky and then back to land to sky, like that in a circle. Back to land to sky.
Like land, sky, land, sky, land, sky.
What are you doing?
I was checking on my tag. I pulled my tag out.
Okay, but this is class, so we're not worried about it, right?
I was seeing if my tag was a stop
Okay, so
tag.
the sun's heat provides energy to evaporate water from the Earth's surface, like oceans, lakes, etc., more. Plants also lose water to the air. This is called transpiration. The water vapor eventually condenses.
You punched me.
Amira, stop it.
Why?
Shuja? All right, Amira, move your seat over here.
No, I'll move my seat.
Both of you guys. Okay, there you go.
I want to be in a video.
You are in a video. The sun's heat provides energy to evaporate water from the Earth's surface. Plants also lose water to the air. And this is called what, Amira?
It is called
Transpiration. Stop it. The water vapor eventually condenses, forming tiny droplets in the clouds. When the clouds meet cool air over land, precipitation is what?
Precipitation is like I'm going around in circles.
No, what is
I
precipitation?
want my sword back.
No, not until after school. Any type of water that falls from the sky.
Rain.
Rain, yes. Sleet, snow, all of that is precipitation. All of this is triggered and water returns to the land or the sea, yes. Some of the precipitation soaks into the ground.
Mommy, is snow the part of clouds?
Yeah, it comes from the sky. Listen. Some of the underground water is trapped between rocks or clay layers. This is called groundwater.
So clouds are made of ice.
Yes. So what's groundwater, Amira?
Groundwater is like the ocean.
No, groundwater is when...
It's like muddy.
No, groundwater is when precipitation that falls from the sky soaks into the ground. And then some of that water gets trapped between rock or clay layers.
Oh.
Or like mud.
Oh.
It gets trapped down into the ground. And this is called...
That's where mudskippers live.
This is called underground water. But most of the water flows downhill as runoff. So runoff is like above ground or underground, eventually returning to the seas as a slightly salty water. No, questions in a little bit. Questions in a little bit.
But I know that fish live in like the...
Okay, questions in a little bit. So we have a... See, look, we have a diagram.
That's
Let's
where
look.
the fish go through.
So we have the transpiration, which is what, Amira?
Which is like the groundwater.
This is when the plants lose water to the air. See? The water kind of makes its way up from the plants or from the ground, which I said it starts in the ground, goes up to the air, see? Then condensation begins.
And then
See?
it's
And then it turns into what, Amira? What happened? Precipitation. I think it's coming back on. Let me see. Yeah, there we go. Turns into precipitation, and then what happens? When it starts to get precipitation in this cloud, which turns into what kind of a cloud?
A rain cloud.
Or no, or what's another word for the storm cloud?
A cumulonimbus
It
cloud.
turns to the cumulonimbus cloud, and then what ends up happening with that precipitation?
And then falls.
It falls from the sky in forms of what, Amira?
And forms rainwater.
Rainwater,
Hail.
hail,
Snow.
snow, and then a mixture of all of them is called what?
Ice.
Sleet.
Oh, sleet.
So then once that precipitation gets into this cloud here and it gets really dark and then it starts to fall. And then that's either, like you said, you named all of the different types of precipitation. It falls to the ground again. It makes its own little cycle back to the ground, and then it either absorbs into the surface, which is called what?
Like
Groundwater. And when it absorbs into the surface, it's called groundwater. Some of it absorbs and some of it does not. And then when the part that doesn't, it's called what?
Mommy, Mommy, is that what this looks like on Earth?
What is it called?
Mommy, is that what it looks like on Earth?
Yes. It's called subsurface or runoff.
Runoff.
Runoff is when the water that does not absorb into the ground pretty much runs off of the land and eventually makes its way to what?
It eventually makes its way to the ocean.
To the ocean or the seas or the river or the lakes.
Mommy, I want it to like that. And then it goes back up.
No, it makes its way to a body of water. And then we go to this cycle again, right? So then we go from the accumulation into the water. Then we go back up into the evaporation into the air. And then we start to meet. Yeah, we start to meet in condensation. What happens in condensation, Amira? What forms when this starts to condensate? It forms clouds. This is where clouds form. And then we go back into our same cycle all over again. So our Earth's atmosphere is constantly working, right? Mm-hmm. Constantly, even on sunny days. That doesn't mean that the condensation or the precipitation or water is not being cycled throughout our atmosphere.
Excuse me?
Yes. Okay.
No, I did pluck her.
Yes, he's going to go by himself in his room in a second.
I did pluck her near her.
Okay, let's keep our hands to ourselves.
No, Mommy, I was like just touched her.
Okay, let's keep our hands to ourselves.
Her.
So, this is called the water cycle or the hydraulic cycle, correct?
Correct.
Okay, so do we know what causes waves, Amira? Don't look at the TV. What do you think causes waves? Don't peek.
Okay.
I have you on camera. Just take a guess. What do you think causes waves?
Air.
Okay. Air. Let's see. What causes waves? The wind causes waves. Thank you, Amira Morris. The wind causes waves on the surface of the oceans and on lakes. The wind transfers some of its energy to the water through friction between the air molecules and water molecules. Stronger winds like storm surges cause larger waves. You can make your own miniature waves by blowing across the surface of a pan of water. So you want to do that later?
Yes! Answer. Yeah.
We could try to see if we can make waves by blowing across a pan of water.
Yes!
Waves of water do not move horizontally. They move up and down. A wave does not represent a flow of water. Okay?
Just give me an answer.
Sit down. Wait your turn. So, this is saying just because there are waves, the ocean has waves, it does not mean that it's flowing water. Correct? Mm-hmm. It's not like a stream. That's flowing water, right? Or sometimes like a rapid river. That's like flowing water. But the ocean's water is not flowing, so they don't want you to get waves confused with water flowing.
Right.
It's not that it's flowing, okay?
It's just that a wind that's pushing it to make it.
So you can see a demonstration of this by watching a floating buoy bob up and down with the wave. It does not, however, move horizontally with the wave. So what this is saying is that when the wave comes and you have a floating buoy, you know what that is? You know the things that float in the ocean? They're like little markers in the ocean.
Like a little tip at
yes.
the top, and then
some of them do. Yes, they have a round floaty at the bottom. So picture that in your head. When the wave comes, should y'all turn yourself around? Give me this. Turn around and look at me. When the wave comes, it doesn't move that buoy, right? I mean, it doesn't move it horizontally. Yeah. That buoy stays stationed. It stays right where it's at, but it just moves up and down with the wave, right? Right. So this is a perfect example to let you know that the water is not flowing, because if it was flowing, it would take the buoy what? With the current. With the current. That's correct. So, now, there are different kinds of waves.
Right.
Okay? Some waves are smaller, like the ones that you see in the ocean every day. Some waves are much larger. And what is that large wave called?
The larger wave is like a surfer. Tsunami.
Tsunami. It's also called a tidal wave. Tsunamis are different from surface waves, like we just talked about. Surface waves are the waves that accumulate from the wind blowing across the water. Tsunamis are different from them. They are usually caused by underwater, what, Shuja? Hush. We talked about this. What happens under the water when the plates shake? Underwater earth. What?
King.
No, what is it called? When the earth shakes. No, Shuja. Earthquake. Careful. Underwater earthquake are caused by, basically is what the tsunamis are. Like we talked about. Sit right, Amira.
Mommy, does it make waves? Does it make waves?
Yes, it makes waves. Me and you talked about this. Sometimes the plate underneath the water will shift or it will slip and fall down. This will cause a huge uproar in the wave or in the ocean.
Mommy, it's a
What?
Mommy, it's a wave. It's a thunder.
No.
No, thunder.
But
lightning.
what ends up happening, like I said, it'll cause a huge wave and in turn cause a volcano. So tsunamis are different from surface waves. They're usually caused by underwater earthquakes. And what else happens underwater, Amira?
Volcanoes.
Volcanoes. So volcanic eruptions do also cause tsunamis. Amira, sit right. Or what else is something that we talked about briefly, when like mud or trees and stuff start to slide down really fast. What is it called? A
landscape.
No, not landscape. So close. A
landslide.
Landslide. So we have volcanoes, volcanic eruptions, underwater earthquakes, and landslides as 3 of the major causes of tsunamis. So, what is a tsunami?
A tsunami is like the wind blowing.
No. Tsunami is different from a surface wave. We already talked about that. Wind blowing across the water causing wave is called a surface wave. Tsunami is not a surface wave. So we just got done saying that it's basically caused by something happening within the ocean, right? Volcanoes, landslides, or earthquakes.
Could you press yarn just to make an amoeba?
So, many tsunamis can be detected before they hit land, and the loss of life can be minimized with the use of modern technology called a seismograph.
Yeah, could you press yarn? Could you press it?
No, listen.
Because you could
No,
slip
Shuja,
it.
let's keep Amira sit right, or you're gonna lose your chair.
How could she lose her chair?
Because I'm gonna take it away. So a seismograph is a device used to detect what?
To detect like a.
How large a earthquake will be. So meteorologists and other people that study storms and earthquakes are able to detect large earthquakes ahead of time, sometimes by using a seismograph. And this would also help for people to detect tsunamis, because when there's a large earthquake, some places are prone, or tsunamis are common to that area, like some parts of Japan. What else? Different parts of Asia, let's just say that. Different parts of Asia are prone to tsunamis. So when an earthquake happens, they will automatically ring the alarm and tell people to get to higher land.
So, what's your point? Like, what do they mean higher land?
Shuja, hush.
Like apartments? What do you guys mean?
Everywhere. Homes, everybody has to get to the higher lands or mountains just in case a tsunami comes in, everybody's out of the lower lands.
What would you put that mean for? Or like a large building, or if there was one in Paris, they would just have to go all the way to the Eiffel Tower.
Well, usually sometimes they build things for tsunami rescues for people to go to. We're doing school. You can ask her later. Hush. Okay, so.
You have to go pee.
Go ahead. So we know that with the use of modern technology, seismographs detect earthquakes. They computerize offshore by buoys that can measure changes in wave heights. So that's another reason why the buoys are there. Remember we were wondering what the buoys are for? Mm-hmm. They can be there to also detect. Somebody can say, whoa, the buoys are getting higher and higher with the waves. Something's going on. The waves are changing, right? Rapidly. So here's a note that you should always remember. If you see the water receding, which means going back, if you see the water receding quickly and unexpectedly from a beach, run towards higher ground or go inland. Leave that area. There may be a tsunami coming. Also, if you are on the coast and there is an earthquake, you may have a tsunami. So run towards higher. You have to wait. Run towards higher ground, and yes, inland, or like all the way up, or like up here. We would be away from the tsunami if it does come in.
So it will be all the way up here at the third floor.
Yeah.
And
it may have caused a tsunami. So run towards higher ground. Are we? Oh, okay.
What about like in basements?
No, that's low.